Assalamu alaikum. Uh, Today I will present our paper ID 330, title Emission Detection on Sility Bangladesh Test, creating a low resource dataset and fine-tuned transformer based approach, and author by MD Arham Ahmed Adil and me, presenter Muhammad Mazharul Islam, and our supervisor is M. Johirul Islam, Professor, Department of Computer Science and Engineering, Shahjalan University of Science and Technology. Introduction. In this area, we will discuss background, challenges, motivation, and contribution. Background. Emotion shape human behavior, decision, and communication. Emotion detection provides deeper insights than basic sentiment analysis. Sility speakers often use Banglish, a mix of Bangla and English, in digital communication and for others linguistic pattern. Context of Sylhet. Sylhet, with its 5 lakh 32,839 population, based on Wikipedia, and 65% on mobile and 43.2% approximately use the internet. Research opportunity. This vast digital footprint offers an opportunity for emotion detection research, but challenges lie in interpreting Sility influenced Banglish text. Challenges in Banglish Sility emotion detection. The complexity of code mixed Banglish text and the unique Sility dialects, phonetic and grammatical structures create significant challenges for NLP systems. The scarcity of annotated datasets, linguistic models, and tools for Banglish Sility text highlights the pressing need for dedicated research. Motivations. The widespread use of Banglish influenced by Sility dialect in digital communication highlights the need for specialized research in emotion detection. Limited resources make it difficult for traditional models to detect emotion in Sility Banglish text. We ourselves are native Sility speakers. Contributions of research. Development of comprehensive emotion detective dataset, and we have built approximately 28,000 data and apply different NLP techniques for regional dialects like BARD models. Literature review. Bangla and Banglish emotion detection and research gap Sility Banglish emotion detection. Emotion detection in Bangla is still limited despite its global rank. Most research focuses on standard Bangla. Dataset like Bengali and Banglish show Banglish models lag behind Bangla. Transformer models, BARD, Bangla BARD, have improved accuracy but struggle with good mixed text. Romanized Bangla shows performance drop in standard NLP models. Research gap. Sility Banglish remains underrepresented in emotion detection. Domain-specific studies overlook regional dialects. Existing models are not optimized for code-mixed dialect-influenced text. No comprehensive data set or benchmark exists for Sility emotion detection. Data collection. Here we will divide this module into 3 submodules: sources of data, data set overview, and observation and limitations. Sources of data. We have collected a small data set from Bashantor, and we also collected from Facebook page and groups like Amla Sility and other pages, and also collected some data from Kaggle English emotion dataset and transferred into original Sylheti dialect, and also I generated some sentences with our own. Dataset overview. Each dataset contains annotated Sylheti Banglish text, and each sample includes ID, text, emotion level. Total sample are 28,093, and emotions are categorized into 7: joy, sadness, and etc. You can see here the percentage of emotion in our dataset. Here joy is likely the greater of everything. Sadness is likely greater, joy is likely greater than everything, and sadness is 30%, and others is lower. Here you can see some sample of our data. Bala Sunni, this led to emotion neutral. Kintam Nai, like it, like annotated anger. Amra Hokol Sylheti neutral. Kita Uigore, it's like fear. Here you can see the word count for each emotion. Like for sadness, here the maximum word is Ami, and for joy also Ami. And here this is like the bag of words, and we just removed this word and cleaned our dataset to mainly focused on emotion, like feel and bhalobasha, more, etc. Observation and limitation. Here you can see dataset significant imbalance, joy, sadness, minority, love, surprise, and textual diversity. Here you can see average text length and vocabulary vary from emotion. Limitation, class imbalance. The skewed distribution can bias models toward majority classes. Limited annotators. Small number of annotators may introduce subjectivity or inconsistency. So, addressing upon this dataset, we resized each emotion category into 40,000 sample and make it oversample dataset. Here you can see the moderate oversampling, full oversampling, and custom oversampling. Here the figure you can see that the different distribution of word, distribution of sentence, emotion in emotion wise. Methodology. This study used a transformer-based approach for emotion detection in Sylheti Banglish. 3 models mainly, multilingual BART, XLM Roberta, and Banglish BART were used for this experiment. And here you can see our main methodology, where Banglish Sylheti, collected Banglish Sylheti text, then pre-processing may remove the unnecessary words, and then we made tokenization, then fine-tuning, then extract feature, then emotion classification, and output and evaluation. Pre-processing. For pre-processing, we simply normalize all text, remove URLs, emojis, and we use a custom script for Banglish BART to unify Bangla and English tokens. For tokenization, for MBART model we use word piece, and for XLM Roberta sentence piece, and for Banglish BART custom tokenizer. And for class imbalance, for handling class imbalance, we used oversampling technique. Training and evaluation. All models are fine-tuned using Adam optimizer with a learning scheduler. Evaluation metrics, we just used F1 score and accuracy for our results and analysis. Here the section is mainly divided into 3 subsections for performance of a BART, XLM Roberta, and Banglish BART. Here you can see the MBART performance. We fine-tuned MBART for both original dataset and modern dataset. Here you can see the table of accuracy of main dataset and oversample dataset with different learning rate. You can see that the maximum accuracy of main dataset is approximately 76% and oversample dataset is 84%. And you can see here the learning rate versus accuracy graph for embedded model. The peak point is 3 minus 5. For XLM Roberta, same way I used same methodology and technique, and for BangladeshBART I used same technique analysis. If I if I think that, then we can see that highest accuracy is 84%, and F1 score is 84%, and for MBART 84% best overall for moderate and actual dataset, and for BangladeshBART is same, and for XLM Roberta. Here model comparison, best accuracy of main dataset or word sample dataset. Here left side showing the MBART model, and middle XLM Roberta, and right side BangladeshBART. You can see that the comparison, the highest accuracy is our sample dataset of MBART model, which is 85%. Okay, from observation I can see stable learning rate at MBART, and best at 3 minus 5, and for XLM Roberta is very sensitive to high. When learning rate 85 minus 5, it dropped, and for BangladeshBART consistent at 2 minus 5 to 3 minus 5, and best at 3 minus 5. Here you can see that the combination of all models, accuracy versus learning rate. Blue represents the MBART, and red represents the BangladeshBART, and other is XLM Roberta. Okay, from dataset impact analysis we can see sadness 30 dominate and love underrepresented. Oversample effect, MBART improvement 9.42%, and but XLM Roberta degrade, and BangladeshBART also improved. Performance deep dive, if I see a difference of two models, MBART versus BangladeshBART, we can see that 2.9% greater from BangladeshBART, and BangladeshBART is for approximately 6% better than XLM Roberta and for others. Ultimately, the MBART is the highest accuracy. Future research direction. Okay, for future worker may be worked on improve annotation quality and multimodal data, audio and visual, and create cross dialect comparative analysis for other dialectual data. And for model development, it can be experimented with other models as well as BART. Conclusion. Okay, transformer based models, especially MBART, proved highly effective capturing emotional nuances, CDT Bangladesh text. The study sets a foundation for future work in underrepresented language, highlights the importance of inclusive, culturally aware NLP technologies. Acknowledgement. We acknowledge to our department and our supervisor, Johari Samsar, for giving us the opportunity to work on this research. Thank you. Assalamu alaikum.